Hello friends. So today we are going to discuss the uses of dimensional analysis. Okay. First is to check the correctness of given equation. Then second is to convert the units in one system and another system. Okay, one system to another system. And third is to find the relation between physical quantities. Okay, normally many scientists give some formula relation between something. U is equal to a plus at something, or s is equal to ut plus 1 upon at square, like that. Okay, how these scientists have derived this formula? With the help of dimensional analysis. Okay, there are some faults, there are some limitations, but it is useful. Okay, so these are the three applications or uses of dimensional analysis that we are going to discuss today. Okay, we will try to understand this through some numericals. So it's very important lecture for you. Okay, for all type of examination, board, NEET, JEE, competition, and whatever. Okay, so attend it from beginning to end. Subscribe my channel if you are not subscribed. Okay, press on bell icon and then click on the notification all. Select all notifications so that you will get all my videos at the instant I upload the videos. Okay, so take your pen, notebook, and let's start. Okay, now look. And another important thing is what? Previously I have uploaded 2 videos on dimensional analysis that are very important. If you understood everything from that videos, you can understand this also. Okay. Applications or uses of dimensional analysis. Dimensional analysis. Okay. Ready? Okay. So first use is what? To find the correctness of a given equation. Okay. Another application is what? To convert units. Means what? Suppose some unit is given in SI, we want in dyne. In a CGS. To convert the units in different system of units. Means from one system of units to another system of units. MKS to CGS, CGS to SI, like that. Okay. So third one is what? To find, this is very important, to find relations between physical quantities. Okay, so this is what these are the 3 applications. So one by one we will try to understand through some numericals. Okay, so let us start with first. Now let us take one example so that you can understand. Example number 1. To find the correctness of the equation. Okay, check following equation correct or not. Okay, so let us take s is equal to ut plus 1 upon 2 at square. Okay, where symbols have usual meaning. Check the following equation is correct or not. S is equal to ut plus 1 upon 2 at square, where symbols have usual meanings. Means what? S is displacement. U is, what is the usual meaning of U? Initial velocity. Okay, T, time. 1 upon 2 constant. A, acceleration, and T is again time. So let us check. Let us check the dimensions of correctness of this equation or this equation is correct or not. Okay, how we can do this? Look, so here dimensions of this term should be equal to dimension of this term should be equal to the dimension of this term. Yes or no? Okay, so left hand side is equal to s. So what are the dimensions of s? Our left hand side dimensions is equal to what? Is equal to what? S means length, so L only. Okay, so L only. Now look, ut, right hand side, dimension of ut. What are the dimension of ut? U means what? Velocity. Okay, dimension of u into dimension of t. So what are the dimension of v? Velocity. Velocity means what? Meter per second. Meter means length. S means time. T minus 1. Okay, into t. Time is t. So this will be L minus 1 plus 1, 0. So L. Okay, yes or no? So dimension of this term should be equal to dimension of this term. So it is there. Then this term, dimension of 1 upon t is a constant, so no problem. So dimension of at square should be equal to this. Then we can say this equation is correct. Okay. So let us find dimension of acceleration. Dimension of acceleration into dimension t square. So what is the dimension of acceleration? Meter per second square. Yes or no? Meter means what? Meter means length. S means t square. So this is L t to the power minus 2. Okay. So let us write here L t to the power minus 2. Okay. And into t square. Time means t square. Right? Now look. Now this will be what? L t minus 2 plus 2, 0. So only L. So L. Okay. So dimensional homogeneity concept, this principle is what? Satisfied. So this equation is correct. This equation is correct. So in this way you can solve. We can check the correctness of the equation. Note down this. We will solve another. So now look, example number 2. Check the correctness of equation T is equal to 4T by R, where T is a surface tension. The formula of surface tension is given, that is force upon length. P is the pressure and R is the radius of the tube. Okay. So we should not bother what is this. Exact meaning of all this we will learn in surface tension chapter. Here everything is given. Based on that only we have to use our concept related to dimensions and we have to solve. So means we have to check the dimension of this side and this side is equal or not. If it is equal, the equation is correct. Okay, let us try. So on the this side, dimension of P, left hand side, dimension of left hand side, so that is equal to dimension of P. So what is P? Pressure. So P is equal to force upon area. Yes or no? What are the dimension of force? M L t to the power minus 2 upon area L square. Yes or no? Now up to now you are familiar with all this dimension of force and area and all that. Okay. So directly I will calculate. So this is M L to the power minus 1 t to the power minus 2. Okay. So these are the dimensions of pressure. Now let us check on right side. Right side is what? Right hand side is what? 4T upon R. 4 is a constant. So no dimensions. T is a force upon area. What are the dimension of T? Force upon area. Okay, dimension of force. This is a force upon force upon R is there, no? R radius means it is a length. And dimension of force dimension, already we know, M1 L1 t to the power minus 2 upon R means length. Okay, so ultimately what are the dimension of this? M t to the power minus 2. Yes or no? L get cancelled. Then R, dimension of R are what? L. Okay, so let us write dimension on the right hand side is equal to what? This M t to the power minus 2 divided by this L. So ultimately what you will get? M L to the power minus 1 t to the power minus 2. Okay, M L to the power minus 1 t to the power minus 2. So left hand side dimensions equal to the right hand side dimensions, means this equation is correct. Means this equation is correct. Got it? Simple. So in this way we can check the correctness of the equation. Okay, so note down this. We will solve or we will see another application, that is to convert the units in one system to another system. Okay, note down this. So second application is conversion of units. So it is used to convert units of physical quantities from one system of unit to another system of units. Means from MKS to CGS, CGS to MKS, or SI to CGS, SI to MKS, or from MKS CGS to SI, or FES also. Okay, so like this we can convert. But how? Using dimension analysis. So let us say for example dimension of force, or sorry, unit of force is Newton. We want, and CGS unit is dyne. Yes, this is SI unit and this is a CGS unit of force. We want to convert how much 1 Newton. We want to find how much 1 Newton is equal to how much dyne. How much dyne we have to find out. So look, how the unit is written, or how any measured quantity is written. Yeah, force is equal to how much Newton. Means this is the value, some value, N1. Okay, N value, NU na. Normally we write NU. Value unit. In this also value unit. So this, let us say for N1 U1 is equal to this N2 is equal to U2. So means how N is equal to 1 Newton, suppose 1 U1 is equal to Newton, U2 is equal to dyne. So we have to find out N2. So 1 Newton is equal to how much dyne? How much dyne? So value of N we will find out. Means we will get the relation 1 Newton is equal to how much dyne. Our conversion of Newton into dyne, that we will do. Now look, Newton means what? Kg meter per second square, and this is what in SI system kg is gram, meter means centimeter, and second square. Okay, so these are the units. This is called Newton and this is called dyne. Yes or no? Now using this relation we have to find out, and using by taking help of dimensions. So what are the dimensions of force? Dimensions of force are what? M L t to the power minus 2. Yes, you know this now. Okay, now look. So what we will do before this? Here we will write the relations. Let us take U1. U1 is equal to 1 Newton. This U1 N1, sorry, N1 is equal to 1 Newton. Then dimensions in units, these 3 terms are there. Let us take M1 is equal to M1 is kg. Then L1 is length, no, so meter, and T1 is second. Here N2 is equal to some dyne, some value we don't know, we have to calculate. Or some number is there, no? Some number is there. N1 is equal to 1 and N2 we have to calculate. Some number you have to calculate. Then M2 is equal to what? In CGS it will be gram. Then L2 is centimeter, and T2 is a second type. Okay. Now what we have to do? We have to use relation. This relation we have to use. Now let us put in this equation this value. N1 is equal to 1. Okay, then u2, u1 is this term, m1, l1, p1 to the power minus 2. Okay, then n2, we don't know that, we have to calculate. So write this m2, l2, t to the power minus 2. Okay, we have to find out n2. So n2 is equal to this divided by this, m1, l1, p1 to the power minus 2 divided by m2, l2, t to the power minus 2. Okay. Okay. Now look. This will be what? We will separate this, m1 divided by m2 into l1 divided by l2 into t1 square, t1 minus raised to minus 2, t2 raised to minus 2. Okay. Now look. M1 is what? M1 is what? M1 is kg. M1 is kg. Kg means in gram. How we can write? If you want to write in terms of gram, M1 is kg. In terms of gram, 10 raised to 3. 10 raised to 3 M2. Yes or no? Or we can write 10 raised to 3 gram. Yes or no? And M2 is 1 gram. Okay. Into L1. L1 is what? Meter. Meter. How meter can be written in centimeter? 10 raised to 2 centimeter. Okay. And L2 is what? Centimeter. M1 is kg. Kg means 10 raised to 3 gram. And this we are not converting, we are writing as it is. L1 is what? L1 is meter. So at the place of meter we can write 10 raised to 2 centimeter. Okay, divided by L2 is centimeter as it is. Into T1 second. 1 second to the power minus 2 upon, this is also same, 1 second to the power minus 2. So this will get cancelled. The remaining this, where I can write here. Now look, N2 is equal to this cancel, this cancel, 10 raised to 5. 10 raised to is equal to what? 10 raised to 5. Okay, means what? N1 U1 is equal to N2 U2. N1 is 1 Newton. U1 is N1 is 1. U1 is Newton. 1 Newton is equal to N2 is what? 10 raised to 5. U2 is diameter. So 1 Newton is equal to 10 raised to 5 diameter. So in this way we can convert SI into CGS. Okay. So note down this. Third application is to find the relation between different physical quantities. Okay. Now how to find? Now look, for that purpose we must know the dependence of one physical quantity to another physical quantity. Means what? Force depends upon what? Mass and acceleration. So by experimentally we have to find out it. Force depends upon mass and acceleration. And by using dimensional analysis we can find the relation between that. Okay. So let us say what is we know force is equal to ma, that we know. But before, for some moment you forget that you don't know this force is equal to ma. Let us assume you don't know this. We want to find out. But something is given to you that force depends upon mass Force is directly proportional to mass. Okay, and force is also directly proportional to A. Force is also directly proportional to A. Let us find the relation between these three physical quantities: force, mass, and acceleration. Okay, so how to do this? So for that, how to solve this type of numerators? So let us say power of m is x, power of a is y. So let us find, use the dimensional analysis and find the relation between these two. Okay, so this f is equal to ma. How it is that we have to find out. Now look. So for that purpose, what we should do? This we can write f is equal to m to the power x, a to the power y. Direct relation is there. It depends. We don't know whether it is directly proportional or not. That also we don't know. Only there is a dependence. Force depends upon mass and acceleration. When acceleration is there, when velocity do not changes, then there is no question of acceleration, so no question of force. Means to increase the speed of a vehicle or a body, we want force. Otherwise, force is not required. Once you give the force, with inertia, body will travel. Okay, what speed of the body is reducing means some additional force is applied on that, friction or air friction or something. Due to that, the deceleration is there. Speed of body is decreasing. To decrease the speed also force is required. Means speeding there is a what you can say, acceleration comes. So whatever it may be, positive acceleration, negative acceleration, whatever it may be, force is required. If force is not there, any kind of force is not there, then body will move with a constant velocity. Means acceleration should be there and mass should be there. Then and only then there is a force will be there. So force depends on mass and acceleration, whether it is directly proportional, inversely proportional, or what are the powers, we don't know. That we have to calculate. So to remove this proportionality sign, we can write f is equal to, let us say, one constant k, m to the power x, a to the power y. M to the power x, a to the power y. Okay. Now, so dimension of on this side should be equal to the dimension on this side. That is our dimension of homogeneity. So let us write the dimension of force. So dimension of force are known: m, l, t to the power minus 2. Okay, this is the dimensionless. So on this side, dimension of mass m raised to power x. On this side, dimension of acceleration. Acceleration is meter per second square. Meter per second square means what? Meter per second square means what? Kg. Sorry, meter means what? Length, t to the power minus 2. So m, t to the power minus 2. Okay. Now this will be what? M, L, t to the power minus 2. This will be m to the power x plus 1. Okay. And t to the power minus 2. Means what? And there is no L on this side. There is no L. Yes or no? There is no L. So, this x plus 1 should be equal to 1. This L is not there. So, this no, here y is there, no? Look. This t means what? T to the power minus 2 into its power should be here y. M raised to x. Here its power should be y. M to the power x, a to the power y. Okay. Xy. Now look, m to the power x on this side, here m to the power y, and t to the power m or l, meter per second square, no? So L. L to the power y and t to the power minus 2y. Okay, t to the power minus 2y. So this m L t to the power minus 2, this is equal to what? M x L to the power y and t to the power minus 2y. So this is equal to what? X is equal to 1, L is equal to, or y is equal to 1 and t is equal to what? Minus 2y, minus 2y is equal to minus 2. So minus 2 cancel, y is equal to 1. Okay, so x is equal to 1, y is equal to 1 we are getting. Means what is the relation? F is equal to k, m to the power 1, a to the power 1, means f is equal to k m a. And value of k we cannot calculate by using dimensional analysis. This is the drawback of dimensional analysis. So for that purpose, to find value of k, we do some experimentation. We have to take a lot many reading, and from that we have to judge, we have to calculate the value of k. And that value of k already which is calculated by the scientist, that is 1. Okay, so force is equal to ma. Okay, but in the examination you don't know this experimentation or all that. So we cannot write like this. This is your answer. F is equal to km. We know this because already it is given in the books or by the scientist, that is value of k is 1. So normally we are using F is equal to ma, but basically in dimensional analysis this is your answer. F is equal to kma. This is the relation between, to find the relation between force, mass and acceleration, and this is the relation. Okay, so in this way we can find the relation between different physical quantities by using dimensional analysis. So these are the applications. You practice more number of problems. I have given hints. 1 problem, 2 3 problem, 3 4 problems we have solved. Okay, so I will finish this topic here. I will declare the topic is over. Units and measurement, unit number 1. Okay, in this what we have learned? Basic lecture number 1, basics of units, basic of units and measurement, that is physical quantities, fundamental quantities, derived quantities, a lot many things. Then error analysis, 3-4 videos we have taken, and on dimension analysis 3 videos we have recorded. So you watch all these videos and practice more number of problems. Practice more number of problems. At the end of syllabus, again in detail we will see this units and dimensions. In the first lecture itself I told you that this unit, chapter number 1, we have to learn again at the end of syllabus, because lot many physical quantities you have to learn in different chapters, in the class 1, class 11 and class 12, first year and second year of PUC. Okay, so at the end again we will record some more videos based on this chapter. Okay, so timing will stop here. You practice more number of problems from the book. Okay, best of luck.